Welcome back to B Spice. In this session, we'll discuss about a new topic, UPS, uninterrupted power supply. So this is the look and feel, the schematic, wherein you'll have the mains and you have a rectifier, wherein the AC is converted into DC, then you have a battery assembly, then you have another inverter, which is DC to AC, then it goes to the load. Okay, and we have a static switches also. We'll explain all these functionalities in this session. In fact, this was asked by one of our viewers. That's why I'm uploading. Okay, let's go into the detail. Let's talk about intro first. What is UPS? UPS mainly includes a rectifier. Okay, then you have an inverter. Okay, and you have a battery, right? Then we have a static switch. So these are the components of a UPS. Very simple, isn't it? Okay. So during normal power supply, the mains power enters the UPS and the rectifier converts the AC power into DC power, right? Right. On the one hand, it charges the battery. Okay, it comes like this and it charges the battery. Okay, and stores the electrical energy. And on the other hand, the DC power is converted back to AC power through the inverter to power the load equipment. Okay, so that is what is happening inside. Okay. Now, when the main power fails, the battery will be discharged immediately and the discharged DC power will be converted into AC power through the inverter, okay, and continue to supply power to the load to ensure the normal operation of the equipment. Clear, right? Yes. So the static switch here, right? This will quickly switch the circuit to ensure the continuity of the power supply. Okay, so that is the working principle of this UPS. Here, one point I want to inform you: this UPS differs from the emergency power or standby generator. You know the EDG, right? Yeah. So in that, it will provide a near instantaneous protection from the input power supply interruption. By supplying the energy stored in batteries. So there is no interruption, near instantaneous protection. That is what it differs from the emergency power. So the on-time battery runtime of an uninterrupted power source is relatively short. Can be a few minutes to several hours. Okay, it depends on your configuration and design. See, normally like 3 to 4 hours is good enough. But sufficient to start a standby power source or properly shut down the equipment which are to be protected. So again, this battery time is depends on your specification or depends on your requirement. In fact, in one of my project, the recent project, we opted for 3 hours. But there is also a call for 8 hours. That will actually add a modification to the design. You'll have a higher size require battery and all. Okay, so it depends again. That's a point. Okay, then the primary role. What is the primary role? To provide a short-term power when the input power source fails. However, most UPS are also capable in varying degree of correcting the common utility power problem. Okay, like voltage spike or sustained over voltage or momentary or sustained reduction in input voltage, noise as defined as a high frequency transient or oscillation usually injected into the line by the nearby equipment, instability of the main supply frequency, and of main, most importantly, the harmonic distortion. So what is the harmonic distortion? Basically a departure from ideal sinusoidal waveform expected on line. Okay, so UPS also capable of correcting all these aspects. That is the point. Voltage spike, momentary or sustained reduction in input voltage, noise, instability, and harmonic distortion. Good to go, friends. Right. So this is all about the basics. Okay. Now we go into the details. Types. So single conversion system. We have a double conversion and modular system. Okay. multi-mode system. Sorry, yeah. So let us start with a single conversion system. Okay. So in single conversion system, we have a standby offline type and line interactive type. So single conversion, of course, we are going to talk about the help of a schematic. So here, single conversion UPS are more efficient than double conversion, but offer less protection. So that is the issue. So just considering the huge, requirement in a big plant, so the protection is also important, right? So we will see that in double conversion. So the point is single conversion are more efficient than, but offer less protection, and it could fit for loads with a higher tolerance of failure. Okay, right. So meaning if we can tolerate, then okay, we can use it. Otherwise, we have to go for double conversion. So that is the point. So standby offline UPS, the most basic type of single conversion UPS, are generally the best option for smaller application, like desktop, while a line interactive UPS are typically preferable for a smaller server, a network application located in facility with a relatively trouble-free AC power. So that is a point. So single power, single conversion, we have a standby and offline. So in the standby offline UPS, the most basic type of single conversion are generally a good fit for desktop. Okay. And another one is a line interactive that are typically preferable for a smaller server or network application. Okay. Got it, friends? Good. This is about the single conversion. So double conversion type. I'm only focusing the concept. I'll explain the details in the subsequent slides. So double conversion. Double conversion, we have an online type. So it provides a high level of protection, as I highlighted earlier, but less efficient, but are usually a standard choice for protecting mission critical system, very critical system. This is the a better fit actually. Okay. Then multi-mode. See, multi-mode is nothing but it's a combination of line interactive and online, right? So it's expensive, of course, than either a single or double because it's the combination of both, right? Line interactive and online. So that is what. And best choice for companies looking to achieve an optimal blend of both efficiency and protection. So this all about the outline about the UPS types. Now we go into a dive deep. Okay, single conversion system. Okay, this is the typical look and feel, friends. So as you can see, this is the AC source actually. So it is this is your battery and this is your inverter and this is your load. Just see the flow, normal flow. This is the normal flow from AC main to the active load. Okay, then this is your stored energy power flow. So this is the stored energy power flow. From here it goes, right, goes here and store energy, right. Then this is the recharge energy flow. This is the recharge energy flow. Okay. So in normal operation, these incoming feed AC power to the equipment. As simple as that. If the AC input supply fails, so the UPS utilizes its inverter, okay, to draw current from the battery, right? Current from the battery, right? Yes, yes, and disconnects disconnects the input supply, okay, to prevent backfeed from the inverter to the utility, okay. So that is how it works actually, single conversion. So add on few more. UPS stays on battery. Okay, the UPS stays on battery until AC input returns to a normal tolerance or battery runs out of power, whichever happens first. Okay, then two of the most popular single conversion are standby offline and line interactive. Okay, now let's see what is standby offline and line interactive. Okay, here the same diagram, whatever, see source, the battery, the inverter and IT load. Okay, the system allow the equipment to run on utility power until UPS detect a problem. Okay, at which point it switches to the battery mode, battery power. Okay, this is a standby. It's in the standby till it detects the power system failure on the input side. Okay, right. So some standby offline design incorporate transformers also, or other device to provide very limited power conditioning as well. So some device, actually some type also provide a transformer side, which we are not discussing here in detail. Okay, right. So this is the standby offline type. Then we have a line interactive type. Just see the difference here. So you have a AC source, a battery, inverter, and it connected to the load. Only thing is here we have a power interface here. Okay. So the system regulates the AC supply voltage up or down as necessary before it passes through the device. That's it. So the line interactive type is, it adjusts the supply up and down. So that is the only difference here. Okay. Similar to the standby and offline UPS, use their battery to guard against protection, guard against frequency abnormalities. So there is no difference there, standby. It's almost same actually. Okay. So this is about the line interactive. Okay, good. Now double conversion. We will see the double conversion. What is happening okay, maybe before that, let us see here AC source. You have your rectifier charger, right? This is what the AC to DC. Then you have an inverter, the DC to AC, then goes to the load. You have the battery here, and of course you have the static switch mechanism. Okay. So this green one is a normal power. Then the stored energy power flow. This is from the battery to this. And you have a recharge flow. This one, battery to the source. Okay. Yeah, source to the battery. Then you have the emergency power. This is the emergency bypass. Okay. So now let us see, as the name suggests, this device convert power twice. Here once and here once. As simple as that. First, an input rectifier, okay, converts the AC power into a DC and feeds to an inverter, okay, output inverter. So the output inverter then process the power back to AC, okay, before sending to the equipment, okay. So yeah, so this double conversion process basically isolates the critical load from incoming raw utility power completely, ensuring sorry, this double conversion protects them or isolates the critical loads from the incoming raw utility power completely, ensuring that equipment always receive only clean, reliable supply. So that is the advantage of this double conversion, friends. So in a normal operation, a double conversion UPS system processes power twice. Okay, normal operation. Okay. So during if the AC input falls out of the predefined limit, the input rectifier, this guy, right, this shut off, and the output inverter begins to draw power from the battery instead. Okay. So the UPS system stays on battery until AC power supply returns to normal tolerance or battery out of power, whichever happens first. This is what happening. So in case of a severe overload of the inverter, here, severe overload of the inverter of a failure, or failure of a rectifier or inverter, here the static guy, the static bypass switch is turned on to quickly support the output load. That's it. You got it, friends? In case if anything overload happens here, the static bypass will switch will turned on to support the output load. Okay. So this is about the double conversion. Multi-mode. So as I said, it's a combination of what do you call single double conversion and this one. Okay. So again, it's a combined feature of single and double conversion and provides improvement in efficiency and reliability. Okay. As you can see here, the same thing here, AC to DC, the DC to AC, that is there. And you have a maintenance bypass and you have a static switch actually. So this is the normal mode power flow. Oh, this one is a normal flow. The green one is the normal mode power on flow. And the blue one, you have this is the normal mode 2 power flow. And of course, this one is from the battery stored energy power flow. And this is the recharge energy flow. And this is your maintenance bypass. Okay. So under normal condition, system operates in line interactive mode. saving energy and money while also keeping voltage with tolerance and resolving common abnormalities found in utility power, right? So whatever is happening here, the input supply, that will not affect the load. So that is the line interactive mode, isn't it? Yes. So now, if power fails actually, okay, the system automatically switch to the double conversion mode here. This happened to the double conversion mode, completely isolating the equipment from the incoming source, so that the power is very clean. Okay, so if the AC input power fails outside the tolerance of double conversion rectifier, here again outside the tolerance of double conversion rectifier, okay, or goes out altogether, the UPS uses the battery here, this battery to keep the supported load. Okay, so that is what is happening, friends. Multi-mode. So basically, multi-mode is a combination of single and double conversion. Okay, good. So when the generator comes online, the UPS switches to double conversion mode again to until the input power stabilizer. Then in transition back to the high efficiency line interactive mode. So that is what happens. So multi-mode UPS are generally designed actually to dynamically strike the ideal balance between efficiency and protection. That is what. If you want a good efficiency and protection, we can go for this multi-mode system. So that's all I have for this UPS. It's basically an outline actually. Next video we'll see an interesting part on modular UPS. What is modular UPS? What is the benefits? And the subsequent video will talk about the comparison between the conventional UPS and modular UPS. Stay tuned and take care, friends. If you want to support, you can show your support either by pressing the thumbs up button or by subscribing, or if possible, can become a member. Okay, thank you. Take care. Bye-bye.